video, we're going to talk about interference patterns. And interference patterns are ones where waves will combine in some way to have an increase or decrease in their amplitude. So first, let's define interference. Interference is whenever two or more waves overlap. So two or more waves overlap. And depending on how they overlap will tell us if it's constructive or destructive interference. So we'll start with constructive interference. Constructive interference is when we have two waves that overlap where the same component overlaps. So here, in a transverse wave, we have a crest that overlaps a crest. And whenever the two crests overlap, it causes an increased amplitude. So it'll be taller. So in our little diagram here, we have one crest and two crests that are both traveling towards each other. And when they meet, we have an increased amplitude. And notice, since these are both initially a small amplitude equal size, whenever they constructively interfere, you get twice as tall. So they add together. Once the interference happens, the waves just continue in their path. So the two waves will travel and they will just continue, but they happen to overlap at one point. So here's an animation of constructive interference. What I want you to do is pay attention to each individual oscillation. So the small oscillation here just travels. The tall oscillation also just travels. But it happens to be whenever the two meet, they interfere with each other and cause an increase in amplitude. And what you should notice is that, again, the two amplitudes will add together. So you add the amplitudes. Here's a picture of a water wave that we see constructive interference. So two waves met, caused a humongous wave in the water, and this is a real picture. It is not photoshopped. The other type is destructive interference, and destructive is exactly what it sounds like. Whenever the two waves meet, they destroy their amplitudes. But the two waves, just like with constructive, will continue to move. So we have two individual waves that, after interfering with each other, will continue as two separate waves. So destructive is when the crest of one overlaps the trough of another. And since they're going in opposite directions, like any vector quantity we've talked about so far this semester, you will subtract them. So you'll cause a smaller amplitude. So in our little diagram here, we have a crest on the left and a trough on the right. And as they travel together, since they are of equal size, they will completely cancel each other out. So destructive interference decreases the amplitude or cancels it completely. But what I really want you to notice is the last line here, where we start with the initial trough and it continues to the left after the interference. And then we look at the crest and it continues to the right after the interference. So even though initially, whenever they met, they interfered and canceled out, the waves still exist. And so they continue after that interference.